Students, today we learn about speed and velocity. So what is the difference between speed and velocity? First of all, we learn about the speed. What is speed? It is the total distance traveled upon time required. That means it is the ratio of distance upon time. Distance upon time. So if we take the example of a car traveling from point P to point Q, so the distance from between point P and point Q is 360 meters. So the time required is suppose 2 minutes. So the speed will be 360 upon 2 minutes. Yeah. Now we will learn about velocity. What is the velocity? The distance traveled in a particular direction by an object in unit time is called its velocity. So velocity definition is also distance upon time. Then what is the difference between speed and velocity? So the speed does not require direction, but velocity requires direction. Another definition is the displacement that occurs in unit time is called velocity. So the formula of the velocity will be displacement upon time, and the formula of speed is distance upon time. From this we are aware of that the units of speed and velocity are the same, and the SI unit of the speed and velocity is meter per second. So the distance is measured in meter and time is measured in second, while the CGS system it is centimeter per second. Speed is related to distance and velocity is related to displacement. If the motion is along a straight line, the values of speed and velocity are the same. Otherwise, they can be different. Velocity is the displacement that occurs in unit time. So what we can understand from this speed and velocity, the speed is distance upon time and velocity is displacement upon time. So the velocity requires the particular direction, and speed does not require a particular direction. That is the difference between both of them. That means speed is a scalar quantity and velocity is a vector quantity. Now we will solve an example. Previous example of Sheetal and Prasha. So they are traveling from their home to school. Now the Sheetal speed along path A Sheetal speed along path A. So we know the formula of speed. First is Sheetal's speed along path A. What is the formula? Distance upon time. How much is the distance along path A? It is 500 meter. 500 meter. And suppose the time required is 5 minutes. Sheetal and Sangeeta house is 500 meter, and that between Sangeeta's house and school is 1200 meter. Along the straight line, distance between Sheetal's house and school is 1300 meter. Suppose Sheetal takes 5 minutes to reach Sangeeta's house and then 24 minutes to reach school from there. The time required for Sheetal to reach Sangeeta's house is 5 minutes, and from Sangeeta's house to school is 24 minutes. So thus Sheetal speed along path A will be distance upon time. The distance is 500 meter upon time required is 5 minutes. If we solve this, we will get 100 meter per minute. Now Sheetal's speed along path B will be the same formula, distance upon time. Along path B, the total distance is 1200 meter and time required is 24 minutes. So 1200 upon 24. If we solve this, we will get 50 meter per minute. Now Sheetal's average speed. Average speed, that means we have calculated the total distance, that is 500 plus 1200 and total time 5 plus 24. Now, total distance upon total time, how much it is. So it is 500 plus 1200, that means 1700. 5 plus 24, that means 29 minutes. If you solve this, we will get the answer 58.6 meter per minute. This is Sheetal's average speed. Now we will calculate the Sheetal's velocity. The formula is displacement upon time. Displacement means the minimum distance between 2 points. The minimum distance is, how much is the minimum distance? It is 1300 meter from point A, this point, from her home to school. The minimum distance is 1300 meter. So it will be 1300 meter. Our total time, that is 29 minutes. If we solve this, we will get 44.83 meter per minute. From this example, we understood that speed depends upon distance upon time and velocity depends on displacement upon time. So we know the definition of the displacement, that is the minimum distance between 2 points. Okay. So now we'll go to our another point, effect of speed and this direction on velocity. We have 3 examples. In first example, the motorcycle is traveling along a straight path. So what will be the effect on the velocity of the motorcycle if its speed increases or decreases but its direction remains unchanged? So he is going in this straight direction, but he is increasing or decreasing its speed. So what will be the effect of the velocity? Changing the speed while keeping the direction same, the velocity also change. In this first. And second, the motorcycle is taking a turn. In this condition, his direction is continuously changing, but he is keeping his speed constant. What will be the effect on the velocity? He is keeping his speed constant, but the direction is continuously changing. This means that the velocity also changing. In third direction, this is the curve path, this is a motorcycle car racing. in this Sachin changing the direction as well as the speed of the motorcycle, what will be the effect of it? So in every turn he has to change the direction, he has to change its speed, so the velocity is also changed. So in three examples, the velocity of the motorcyclist is changing respective conditions. Now we move to the next point, that is uniform and non-uniform linear motion. We have example in which three persons are given, Amar, Akbar and Anthony. They are traveling a distance in kilometers. Suppose they have started their traveling at 5 o'clock, and after half an hour we noted their distance. The distance is recorded after every half an hour. So we get the total readings from time 5 to 8 after each half an hour interval. The distance traveled by the Amar, Akbar and Anthony is recorded. So we have some questions. What is the time interval between the notings of distances made by Amar, Akbar and Anthony? The time interval is half an hour, 30 minutes. Who has covered equal distances in equal time intervals? If you look to the condition, Amar has traveled 20 kilometers in each half an hour, but Akbar doesn't travel equal distance. In first half an hour he traveled 18, in next half an hour he traveled 36, in next half an hour he traveled only 7 kilometers. So the distance traveled by the Akbar in each half an hour is not same. Now we look to the Anthony. Anthony traveled 14 kilometers in each half an hour. So the same equal distance traveled in equal time by Amar and Anthony. Are all the distances covered by Akbar in the fixed time intervals the same? No, it is not same. In first half an hour he traveled 18 kilometers, in next half an hour he traveled 18 kilometers, in next half an hour he traveled only 7 kilometers, then next half he travels 28 kilometers, in next half 25 and again 25. So the time interval traveled by Akbar in each half and half hour time interval is not same. Considering the distance covered by Akbar, Amar and Anthony in fixed time interval, who can you say about their speeds? We can say about that Amar and Anthony has equal speed because they travel equal distance in equal time interval, but Akbar does not have equal speed or same speed. So we have two definitions from this. Uniform speed. What is uniform speed? If an object covers equal distances in equal time intervals. Equal distances in equal time intervals, it is said to be moving with uniform speed. समान वेळेमध्ये जर समान अंतर पार करत असेल तर त्याला आपण युनिफॉर्म स्पीड म्हणतो. What about non-uniform speed? If an object covers an unequal distances in equal time intervals, it is said to be moving with non-uniform speed. Unequal distances in equal time intervals, then it is non-uniform speed. Unequal distance in equal time. That is the example of Akbar. So Amar and Anthony is having uniform speed and Akbar is having non-uniform speed. So today we learn about velocity, speed, uniform and non-uniform linear motion.